Now we are going to discuss this question where it is asked infinite number of capacitors are connected to microfarad each and you are to calculate the equivalent capacitance. For this, at first you have to observe or you have to find some pattern in the circuit, and if we observe you will find that means between A and B we are to calculate equivalent capacitance. Now see, these two are in parallel because from here you see these 2 microfarad and these 2 microfarad, we are talking about these two are in parallel connection because same amount of charges does not pass through this. Next, again you come here, these two are parallel. From here these two are parallel. That means the pattern is this, or this is one unit. This unit is repeated infinitely many times. This here, second, third, like this way. Infinite number of times this unit is repeated. Now you see, we don't know what's the equivalent capacitance. Let the equivalent capacitance of the entire circuit be X. For the entire circuit, equivalent capacitance we assumed as X. Then this circuit is consist of infinite number of such units, 1, 2, 3, like this. As there are infinite number of such units, and if you keep it isolated, then also for the rest of the part equivalent capacitance will be your X. I repeat, if you have 1 kg of salt and if you take out 1 crystal of salt from there, then also it is 1 kg. So it's like that. As there are infinitely many units are there, then we will keep it isolated. Then for this rest of the part, this capacitance is also X. It can be assumed. Then what happens you see? Here, this unit kept isolated. This 2 microfarad and this is your 2 microfarad. And from here, rest of the part we can take it as X. So, say this equivalent capacitance for this, again it is X. Here it is A and it is your, say, B. Now see, this reduces to this part. You may be confused that how it is X, because I repeat the fact, the entire circuit having infinite number of such units, and if you reduce 1 or 2 units from here, then also rest of the part can be assumed as X. Then here you see these 2 and X. These 2 capacitors are in your series connection. It is clear how to decide. Charge flows across this and same charge flows through this capacitor. Then 2 and X are in series. They are in series. But as you know, if these two are in series, the total capacitance for these two capacitors is your twice X over 2 plus X. Directly you can write. Means C1 and C2 are in series. Then equivalent capacitance is C1 C2 by C1 plus C2. It comes from that fact 1 by C equals to 1 by C1 plus 1 by C2. So directly we can write this. So this is your total capacitance of these two capacitors. Then you see, now these two and this capacitance are in parallel. Then these 2 microfarad and total capacitance of these two, that is 2x over 2 plus x, are in parallel connection. Are in parallel. That's it. Now, as they are in parallel, then total capacitance will be directly sum of the capacitance. Therefore, or you can say equivalent capacitance, C equivalent equals to 2 plus 2x over 2 plus x. If you simplify this, LCM is 2 plus x, then it is your 4 plus 2x plus 2x, which is equal to 4 plus 4x over 2 plus x. So, and this is your equivalent capacitance of the entire circuit, and which we assumed as x already. That's why this value must be equal to x. Now rest of the part is simple mathematics. Then you see, therefore what you can say, 4 plus 4x over 2 plus x. It is the total capacitance we have calculated for this circuit and which we assumed as x. Cross multiply this, 2x plus x squared equals to 4 plus 4x. Then what quadratic equation comes? X squared minus 2x minus 4 is equal to 0. Now see, factorization is not possible, so you have to go for quadratic formula in order to solve this. Then let me run this part now. Here A is your 1, B is your negative 2, C is your negative 4. Calculate the discriminant, B square minus 4AC, that is your 4, and it will be plus 16, that is your 20. Now use the quadratic formula to get the solution of x. So x is equal to minus b, that is your plus 2, plus minus under root over b square minus 4ac, that you have calculated as 20. Divided by twice of a, this is your 2, which is equals to 2 plus minus 4 into 5. So 2 take out twice of root 5 by 2. Then finally, x is equals to 2 common cancel out, 1 plus minus under root over 5. It's very much clear, root 5 is greater than, that means 2 roots you get from here. 2 roots possible. One is your 1 plus root 5, other is your 1 minus root 5. 1 minus root 5 will give you negative value, and where x is the equivalent capacitance of the entire circuit, capacitance cannot be negative. That's why 1 minus root 5 is not possible. So equivalent capacitance, now you can say C equivalent, it is confirmed, that is your 1 plus root 5. This is your answer. And if you want to get the answer in decimal point, then you have to calculate the square root of 5. So how to calculate? Let me share a trick here. Say root 5. We are calculating the value of root 5. Within a couple of seconds you can calculate this. You think of root 5 can be written as, think of a number which is perfect square but just smaller than, just close to 5. It may be greater than 5, it may be smaller than 5, nearest to 5 I mean to say. Then that is your what? 4. 4 plus 1 you write. After that, under root over 4, directly take this, plus this is your 1 by simply 2 into root over, what is it? 4. So from here you will get root over 4 is 2, plus it is your 1 by 4. As you know, 1 by 4 is how much? That is your 2 plus 1 by 4 is your 0.25. That is nothing but 2.25. This is the value of root 5. Then in place of root 5, let us write 2.25. This is equal to 1 plus 2.25. That is your 3.25. This is your answer. So equivalent capacitance of this circuit is your 3.25. Next we are going to take some another types of questions where infinitely many resistors are capacitance are connected. Thank you.